All right. Hey everyone. This is Jeff. I am hopefully, if you're watching this, your TA for DSUA111, and I actually did this session twice last week, like live, but I got a very distressing email that I had forgotten to press record when I did those two sections, so a bunch of students were unable to access it. Well, unless you went live, you were unable to access it. So I'm really sorry about that. If you're, watching or recording this, well, yeah, I'm just recording it now for you. So if you're watching or recording this, I'm sorry. From now on, I'll remember to press record, and you will get the section videos like right when it finishes. So if you're in section 007, you'll get it, at let's see that one. So it's basically you'll get it by Friday evening. Yeah, both of the section videos will be available and you can watch either one. But yeah, for this week, this is a special video because I got emails that I had forgotten to press record. And so this is the redo of the Friday section from, what would that be? So the section from like Friday, September 4th. Cool. Let me start sharing my screen because I have slides. Yeah, hopefully you can see this. DSUA111, data science for everyone. NYU, fall 2020, and a key link for if you're watching it is this GitHub link right here. So it's just github.com/jpowerj. That's my GitHub username, and then DSUA111-sections. So like if you click that, you'll see this, and it looks a little like, what do I do? But just for now, click this week00.ipynb file. The slides are here, but GitHub doesn't render HTML slides. Like it'll just show you code, so you don't want that one. Right, like this is not good. What you want is this one, the ipynb file, because GitHub will render it and you'll be able to see all the materials. So this is just like, basically like I just have this is actually Jupyter. This is what you'll be using the whole semester, but there's a way to convert Jupyter notebooks into slides. So that's all I did. So I wouldn't worry about the slides. Like I can get you the slides as like a PDF. Maybe I'll do that. I'll post the PDF of the slides, but all the materials in here, right? So these are all the slides, just each different part of this notebook right here is one of the slides. So you're not missing anything. So yeah, if you post this, and I'll just put it in the chat because I think if you watch a Zoom recording, you might be able to view the chat. I don't know, but just in case, I'm going to put it in the chat real quick. So copy. I don't know, and if there's no chat, then just try and type in github.com/jpowerj/DSUA111 sections into your web browser. But cool. So this is an outline of what we'll talk about. Basically, I'll just give a super quick intro. I don't think it's that important who I am, but contacting me can be important because I got a email from Prof. JR saying that someone had said they tried to email me and couldn't access. I didn't receive any emails, so yeah, we'll go through that. But the key thing we'll do today is I'm just going to go through the 4 main resources you're going to use in this class. The first is NYU classes. The second is Jupyter Hub. The third is NYU Drive right here, which is related to auto grading of the course assignments. And then Piazza. And then I'll end with just a super, super quick like rundown of what exactly data science is in my view, right? Because my view is probably a little different from Prof. JR's, so just probably different from Prof. Sperling's. So yeah, we'll just kind of get that all on the table. And then next week we'll start like, actual content. But this is just like an intro lecture. So yeah, I'm Jeff Jacobs. I'm a little weird because I'm a PhD student up at Columbia University, not NYU, but yeah, in hindsight, I definitely should have gone to NYU. Like the data science and especially what I do, which is kind of like text, like natural language processing, text processing. There's a ton of cool stuff at NYU. So yeah, I'm a PhD student at Columbia, but I am teaching here at NYU, and I actually work with a lot of just like NYU data science people through like, research projects and stuff. And then I'm also I like write for this think tank type thing called Jane Family Institute, JFI. So just I only include that because it's like I do pretty much everything I can to get back to your emails within 24 hours. And I think I've done that so far, right? Like but just in case like you don't receive a reply, something probably blew up at one of these other two, jobs that I'm trying to do this semester. So like I have a research assistantship at Columbia, and then JFI is like a writer person. Yeah, so then past life, like I was kind of hired for this, I think, as like the person with like a computer science background, because I actually switched into the PhD program I'm in right now, which I sort of should have said is in political science, from a computer science program at Stanford. So like I have this kind of dual like background thing. I'm kind of like retraining as a social scientist from like engineering school, like undergrad and first grad program were in like engineering schools. So just like full, had to take like statics and mechanics and all that stuff. Yeah. And then before that, I did my undergrad at University of Maryland, which was in, like computer engineering, but also math and statistics. So yeah, hopefully I can like bring a lot of stuff together for y'all. But if you have questions about like CS as a specific direction, happy to answer those. I'll talk about that more later. Yeah, when I was like a teenager, I tried to be a musician. I failed at that, so now I'm doing academia. But so I'm only half kidding. But yeah, don't worry about that. And then yeah, I included this last thing because I think it also gives like an important context, which is that yeah, I spend every summer in like the West Bank and in the Gaza Strip, basically in the like occupied Palestinian territories, like over in the Middle East. I teach like computer science and then this other thing called design thinking in refugee camps out there. So, that's kind of like my passion project. That's what I do when the school year is out, but I also just include that because like I'm very used to answering questions about like coding and data science and stuff like that from people who have like never touched a computer before in their life, right? Who get like 2 hours, 4 hours of electricity a day. So I say that because it's like if you're thinking that you have a stupid question, like I wouldn't worry about it. I'm very used to like people just coming with like an absurd like range of having never used computers at all or using computers every day for their job or whatever. So yeah, I just wanted to include that as background, but also just to say that like I wouldn't worry about thinking like, oh, Jeff's gonna think my question is dumb. Like I've probably heard it before, if that makes sense. So yeah, please don't worry about that. Just like know that I'm totally down to try and meet people where they're at, whatever level that they're on in terms of like comfort with computers and data science and math stuff. So yeah, cool. That's my email there, jpj251@nyu.edu. And my office hours are Wednesdays, 5 to 6 p.m. New York time. So right now that's like Eastern it's like EDT, Eastern Daylight Savings Time. But yeah, whatever the time is in New York. And yeah, if you look at the slides, they're, in your case, the IPython notebook, IPYNB file. On GitHub, you'll see I put a Google Calendar event just so you can save that in your calendar if you want. And then also this is a direct link to the Zoom room, right? This that I'm recording this on right now is like my personal Zoom meeting room. So yeah, actually you could just bookmark that. And then like, if you're like, oh man, 5 minutes left in Jeff's office hours, and I just realized like I don't understand something from the homework, anything like that. Yeah, just go ahead, you can bookmark that and you can come into that room during my office hours, which are 5 to 6 p.m., like I said, and that's just like right after the Wednesday lecture. So if you're watching the Wednesday lecture and you're like, oh, something that Prof. JR or Prof. Sperling said, like I totally don't get, feel free to come to my office hours right after. Cool. First resource, which is like definitely should be first because it is the resource through which you can access all the other resources of the class, and that's NYU classes, right? So here's a link just to general NYU classes, which hopefully you've seen before, but here is a link I tried to put, I hope it works, specifically to the NYU classes page for this, for DSUA111, right? So if you go here, yeah, you'll have to log in first, but then you should see a interface like this. And I want you to notice in particular this little set of tabs on the left-hand side, because this is like your home base right here, right? This is where you can access all of the materials for the whole class. So you've got the, first you've got the syllabus right here. And Prof. JR went over this in the first lecture, so I won't spend too much time on it, but I just wanted to say like this first page of the syllabus is a pretty good resource because, it has all the times and everything. And it also has emails. These are the professor emails and these are the TA emails. And then also if you look, like there's Zoom links to Prof. Sperling and Prof. JR's Zoom rooms, and same here. It's might be a little unclear, but these, the timings, right? In this row of the table of TA information also links to the Zoom room that I was talking about. So if you don't have it bookmarked, you can remember that, oh, I can go to the syllabus and get just click this Wednesday 5 to 6 p.m. and it'll immediately pop up my Zoom room to attend my office hours. So if all else fails, you have the syllabus, you have a link to my office hours. Cool. Yeah, there's course announcements, there's lectures and homework and exams, but the first link that we'll look at in depth is Jupyter Hub, because Jupyter Hub is kind of the, I'm going back to my slides. I have a direct link to it here. The URL is just dsua-111-fall.rcnyu.org/hub. And I think you have to include the /hub. Sometimes it doesn't load for me if I don't include that, but just in case it helps like with remembering this, because my brain doesn't remember it. It doesn't remember acronyms that well unless I know what they stand for. I think this just means remote cloud, NYU.org. So it's like, it's the NYU cloud software. And in this case, this is our specific like subdomain on the NYU cloud, right? So if we open that, you will see this, right? And you'll sign in with your NYU email. And then you'll see this orange spawn button. And this might seem kind of weird to you because you're like, well, I'll just click it first. But yeah, you have to click that. But you're like, why do I have to spawn? Like, why doesn't it just pop up the Jupyter Hub interface? And that's because NYU has a certain, like the way that it works is it would cost too much money, I guess, or it'd be too costly to run servers all the time, 24/7 for every student. So what they do is they have this like, set of servers that are like dynamically allocated, meaning like what happens is you say, oh, I want to work on the NYU cloud, right? And so you click that spawn button and it like blocks off one of the servers that they have and reserves it for you, right? And like assigns it to you. So that's, I just wanted to explain, that's what's happening when you click spawn, is it's kind of reserving a server for you. That's like important to know only because, well, for a couple of reasons, but one is that it means there's an inactivity shutdown, which is really frustrating. Like I've lost a lot of work before I kind of got used to that, which is like after I think it's 1 hour of quote unquote inactivity, they'll just shut your server down. And it's really frustrating because you'll lose like anything you've been working on that you haven't saved, right? So that you haven't saved like to your disk space here. So, and what's frustrating about like inactivity, quote unquote, is that it might seem like activity to you, but the computer or the server will interpret it as inactivity, because what it means by that is time since you've like saved something on the disk space, right? So if you're like working on a homework and you don't save it, it's gonna think you're inactive, even though you're active, right? Like you're typing in the cells, you're typing in the homework answers, but it's gonna think you're inactive if you're not saving the file a bunch of times. So I always just like save basically after I write anything, just so that it, so that I don't lose work. And yet, you know, easier said than done, I've lost a bunch. So that's actually why I'm actually gonna recommend like maybe installing this program, Jupyter, on your local laptop. And I'll talk about that next week. But yeah, this is not like some special, like fancy, you know, proprietary software that NYU has. Jupyter is just like a free open source program that you can install on your laptop or desktop or whatever you have on your local machine. So, and then, you know, there's no inactivity shutdown. You'll just be able to run it on your laptop whenever you want. So I'm going to show you how to do that. And like, that's what I do nowadays, because I'm just too scared of losing my work because of the inactivity thing. But you'll be submitting, you'll be fetching and submitting the homework assignments through this, right, through the online Jupyter Hub. So you still have to use it no matter what. I'm just saying that, you know, I mean, most people go through the semester just fine using the rcnyu.org cloud, but I'm just saying, like, if you're worried about that, like if that scares you, like you can install it on your computer and not worry about it. So cool, talk about that later next week. But for now, we're gonna work on here, and this first thing that it shows you is just like the contents of your home folder, right? So this little like folder icon here, that's kind of the like code or the symbol in Jupyter for your home folder, right? Meaning like if I go into some other folder here, right, you'll see it's like home folder / lost and found. And you can click on that icon to go back to the home folder. Cool, so just if I say home folder, that's what I mean. It's like the space on the full, you know, NYU cloud server that is reserved for you. And yeah, these, you won't see these because I just made these, but on .ipynb, it actually stands for IPython notebook, like IPynb, so IPython notebook, but that's just the old name for a Jupyter notebook. It's kind of like, it used to be called IPython. They changed it to Jupyter, but they kept the file extension. So you can, yeah, click on those to open them, but I also want to show you here in the upper right, to make one of these, right, to make your first one, you'll click this new button. So you click that, and then you'll see this there's kind of a horror show of options here that still confuses me every time I click it. So don't worry if it's confusing. But I want to point out that if you want to make a new one of these like Python notebooks, by the way, sorry, Python notebooks are where you'll be like, that's where you actually write Python code, right? So you're gonna, Python notebook is where you just like, it gives you these little boxes, it's called cells, where you can type in code and then you run the code and see what the output looks like. So that's what I'm talking about here. And to make a new one though, you might think, okay, well, I want to click Python 3, right? Because that's like the Python version that we're using in this class, Python 3. So you might think that, but the issue is that what that will do is that will make a notebook that is using the base Python 3 libraries, which just means like the libraries, so meaning the functions and the variables and the files and everything, the syntax that's built into Python. But in this course, since it's data science and not just like programming in general, we actually have made this like custom version of Python for y'all, which is we needed to do because we have all these additional like data science libraries, right? So data science functions and variables that we needed to install on top of Python for you to use, right? So you'll quickly learn because we'll cover them pretty early on. They're called like pandas is a library for working with data sets. NumPy is a library that adds like additional mathematical and statistical functions onto Python. There's one called matplotlib, which is just a plotting library to make like, you know, bar graphs and scatter plots and stuff. So yeah, that's just wanted to explain. That's why actually when you click new, you want to click the one that says DSUA111, right? It's not the most aesthetically pleasing name, but yeah, Python conda env DSUA-111. That's the one you want to click, right? And when you click that, you'll see your first notebook, right? So it just calls it like untitled, and it gives you this thing that I mentioned is called a cell, right? Where and in the cell you can type code like, I don't know, 1 + 1. There's your first Python code that you've learned. And on PC, I'm working on PC, you hold down shift and you press enter to run the code in the cell that you're typing in. On Mac and Linux, it's, well, on Linux, it's, I think, shift enter or command enter. Well, if you have Linux, you can talk to me and ask, but it's, if you have a Mac, it's command, it's the command, hold down the command key and press enter. But yeah, so that's like the most important keyboard shortcut to know. So I'm holding down shift and I'm pressing enter, and it takes the input, right? And it runs it and it displays what the output is, right? And I can also just use this print function, right? So print hello, and it will output hello, right? Now you might think like, okay, so it just runs like each line that I write in this cell and puts the output, right? But it's a little confusing, and this is not like, we're not doing like a full Python lesson here. So this is not, you're not like responsible to know this. Like we'll do tons of Python in later weeks, but I just wanted to show you like, you know, if you do a bunch of different operations in one cell like this, right? We're doing like 3 different things because of, it's kind of just like a quirk of how Jupyter works. It will only show you the output of the last line in the cell, right? So in this case, like we're doing 3 additions, but it only shows the result of this one because it's the last line in the cell, right? So kind of early on, I want to kind of instill that if you want to view the output of some operation, right, some line of code that you've written, you're pretty much going to want to explicitly use like the print function, right? So because if we explicitly tell Python like, oh, I want to print these 3, the results of these 3 operations, now we'll get to see all 3, right? So yeah, it can get a little confusing because you'll be like, wait, I did a bunch of stuff, but it only outputted one thing. And that's why it only outputs the result of the last line. So if you're doing important stuff that you care about the result of before the last line, yeah, just use the print function. But, we'll spend a lot of time on that. You can click up here on the title to rename it. So be like week 0, right? And now the last important thing that I want you to remember is that, so you'll see up here, it tells us we have unsaved changes, right? Because when it started, it was an empty file, and now there's 3 cells with output. So what I want you to remember is that you can click File and then Save and Checkpoint. It shows that it's also Control S, or I think that would be Command S on Mac. But you want to click this because not only does it save your changes, but the checkpoint part is really nice because once you do that, you'll see that there's a revert to checkpoint option. So like if you mess up something, like you're like, oh man, I accidentally deleted all my code back or something, there's this revert to checkpoint menu, right, where you can go back to an older version of your notebook. So that can be pretty life-saving in a lot of situations, right? But that only happens if you remember to save a checkpoint often, early and often. And then, so that's just to save it. I would just do that like as much as possible because, especially because of the thing I was saying about how it'll shut down the server. And then also close and halt is an important option when you're done working on the notebook, basically because you could just like close the tab, right? Like I could just close this tab, but what that will do is it will keep the notebook like active. And I'll show you what that looks like, which is basically, you see how like these are gray, right? These little notebook icons next to these files, but this one's green, right? So the ones that are filled in green are like active notebooks. And that means that like some part of your processor, of your little server that NYU has allocated is like kind of just sitting there waiting to run cells in this file, right? So kind of means that like a part of your processor is being used on this notebook, right? So if you just like are working on a bunch of different things and you close the tab instead of closing and halting like this, it's going to slow down your server because it's like basically thinks that like it has to allocate all this processor space, let's say, all this processor memory and stuff to that notebook. Whereas like if you close and halt, right, what that does is it shuts it down, right? So now we see a gray icon. And what that means is now like the processor and the memory, the RAM is like freed up to do, you know, whatever. So like you can start a new notebook and then all the processor and RAM is allocated to that notebook now. So it's just, yeah, you don't want to, I do it all the time by accident. I'll just like close the tab or shut down my computer or whatever, and it slows it down after a while. So you want to close and halt your notebooks when you're done working on them. Cool. Now, the other part of Jupyter Hub that you'll need to know is, so far we've been working in this, you see these tabs up here? We've been working in the Files tab, but there's also an Assignments tab, and that's the other tab we're going to focus, we're going to be using a bunch in this class, because when you click that, it's a little, you know, frustrating because we don't have any assignments right now, so I can't really show you exactly what this looks like, but we'll go over it when homework 1 is released. And the point is that this tab shows you like there's these 3 panels, right? And they're ordered in a certain way, where this first panel, right, called released assignments, that those are all the assignments that like are available for you to start working on, right? So when we first release an assignment, it will show up to there. Like this will be a list of all the assignments that are available for you to work on. Right, so when we release homework 1, there'll just be an element here that says homework 1, and you will also, importantly, there will be a big blue button here on the right side that just says fetch, right? So it'll say homework 1 and then fetch, and when you click the fetch button over here, what it'll do is it'll move it down here to the downloaded assignments panel, right? And what that means is that your particular like Jupyter Hub server has gone to our instructor, you know, DSUA111 general server and copied the homework assignment over, right? And so once an assignment appears here, that means it's like copied to your home folder and ready for you to work on, right? So it'll show up here and you'll be able to go back to files and it'll actually make a folder called homework 1 or homework 2 or homework 3, whatever the name of the assignment is, so that, you know, you can open it, right? So you'll see a folder that says homework 1, and inside of that will be just a notebook that says homework1.ipynb, right? And you click on it to open it just like any of these, right? Cool. And I've made a little, you know, sample here to just show you what that will look like, which is that the cells, right, in your notebook, they can, like by default, they're code cells like this, right? So you can do all that, but there's also these text cells, right? And what you'll see when we release the homework is that there's just they're alternating, right? There's a text cell that shows you the question, and then there's a code cell directly underneath it, and that's where we want you to write your answer to the question, right? So here, question 1 is write code to compute 2 times 5, right? And there'll be a blank cell. You'll say, okay, well, here's my answer, 2, and then star, the asterisk is multiply, the multiply symbol in Python, so 2 asterisk 5. And you run it and it produces 10. You say, okay, great, cool, I think that's the right answer. So you save and checkpoint, and then you close and halt, right? So say you've now finished the homework, right? I'm fast forwarding a lot because the homework will be like a bunch of questions, like 30 questions or something. But once you're finished with that, you'll close and halt, and you'll come back to this interface. You'll click the assignments tab, right? And now back in the downloaded assignments section, there will be another big blue button. This time it says submit, right? And when you click that, it will move the assignment from this downloaded assignments panel down to the submitted assignments, right? And actually, once it's submitted, like, you're done. There's nothing else left for you to do here in this interface, because once it's submitted, that means it basically takes the completed homework, right? The homework with your responses filled in, and it copies it back onto the DSUA111 instructor server, which is the grading server, right? And so with that said, yes, go back here, and I'll say, like, the way that your assignments are graded is that, yeah, you submit them from within Jupyter Hub, like we just saw, and then the autograder runs, right? Like, we just get, there's just like a big folder on our server that has all the submissions, right? Every time a student clicks submit, it copies back over to our server, and we have like an autograder. And sorry, the nice thing about the autograder is that, well, I'll say there's some nice things and not nice things about this, but basically we used to use this auto grading software, and it just, like, was really terrible, and it was like getting students' grades wrong, and there was like literally no way to update or anything. So there was like a real nightmare when I first was starting, TAing this class. So basically I sat down with the other, with Prof. JR and the other TAs at that time, and I was just like, we need to like just make a new auto grader. So long story short, like, we made one, which just works a lot better for what we do in this class. And so the good thing about that is, like, we don't need to worry about, contacting tech support or anything for the software. Like, the tech support for the software is like me and the other TAs, right? I keep saying me because, like, long story short, just because of, like, background in CS and everything, like, I just ended up like doing most of the coding. Like, we met and we talked about the features we wanted, but the code is like my responsibility, right? So if there's something wrong with it, I have that here, which is like, if you don't understand your grade or you think something's wrong, email me specifically about it, right? Because that's the nice thing, like I keep saying, is that we can be super responsive, and like, if something's wrong with the grading, we can just go in and like change the code of the auto grader, right? We don't have to, there's no like third party that we have to worry about. So, but the con, right, like that's a pro, but then the bad thing, the potentially bad thing is that because we just wrote it for this class, like, it's not like it's tested on like millions of users in millions of cases and stuff, right? Like some professional software would be. But yeah, just wanted to point that out, because it's like, if something goes wrong, like, you say, wait, I think my response is correct, but it got marked wrong, like, that's very reasonable, and it could happen, right? So if that happens, just please, like, bear with us. Each semester, we improve it more and more as more things come up, and I'll say this is the 4th semester that we've used this new auto grader. So, hopefully most of them like glaring issues with it are patched and fixed and everything, but you never know what will come up. So just, I understand if something like goes wrong with your grade, it's frustrating, because you're like, but I spent all that time, trying to come up with the answer, and I thought I got it, but it marked it wrong. Totally understand that frustration. Just email us and like know that we're not like, we're not sitting here like, no, the auto grader is always right and it's perfect. No, it's like, it's a work in progress in a way. I mean, after about a year now of using it, like it's mostly ready to, it's like mostly works. But yeah, there's still issues that come up every now and then. Cool. So yeah, the autograder runs on our server, and then what happens is it generates a grade, right? Like, oh yeah, sorry, I should have said the way it generates the grade is, I want to like emphasize this, that one, like the autograder is testing two things for each response that you submit, right? The first thing that it's testing is that it produces the correct output, right? So on the like multiply 2 times 5 question, the correct output is 10, right? So the first thing that it checks is the correct answer, right? And that might seem obvious. That might be like, wait, why isn't that the full grade, right? Why is there another thing? And the reason there's another thing is because I'll just show you, like, if you like think about how Python works, right, and how these notebooks work, you could always write a set of code that produces the correct output, but doesn't actually like do what the question is, like wants, what we want you to do, right? So you could do is you could just print 10, right? And then see that produces the correct output. It produces the same output as this, right? But it's not really doing like what we want you to do, right? It's not, we want you to write code that, where the code actually does the computation, right? 2 times 5. And that's clearly not being done here, right? Like you've done the computation in your head and you're just outputting it. That's like a dumb example, but you'll see that like with more complex types of questions, like especially later in the semester, it can be an issue, right? Students will try to like game the system or cheat in some way by just being like, oh, I don't know how to do that computation, but I'll just like do it on a calculator or something and put the answer, right? But one of the main purposes of this class is to like show you how to actually like you write code to do these computations, like do data science, right? So we can't just we can't just check the answer is what I'm getting at, which, and as like in particular, we need to check the actual code that you write, right? So the autograder is not only looking at the answer that it produces, but it's also looking at your code and trying to make sure that you're, doing the computations that we want you to do. So in this case, right, you could imagine that, for example, we look to see that like an actual multiplication is being done somewhere in your code, right? So we could say like, oh, we're looking for the, asterisk, right? There's no asterisk here, so that makes it obvious that like our code is not actually computing any multiplications, right? So yeah, I just wanted to point that out, that like, right, it's looking down here at the output, but it's also looking at your code, right? And it's going to check that your code does the things we expect, like if we expect your code to have like a loop in it, right? You'll learn what that is, but it's just like runs a piece of code a certain number of times instead of just one time. Like we're going to check that your code actually contains the Python keyword to start a loop, right? So just things like that. Hopefully that makes sense. But we've had some, I don't know, there's certain people just think like, oh, but if it produces the correct answer, it must be correct. But think about this case as the most basic case of why, we also we're going to check the content of your code. So cool. Just wanted to point that out, like at the beginning. Anyway, so I save and checkpoint, I close and halt, and back to the slides that, yeah, it'll compute your grade. And the first place that your grade will show up is on NYU classes, right? Back here, you'll see there's a gradebook tab, and that's where your grade will first show up. But that's not really like where we want you to focus on, right? That's just kind of for record keeping. The real thing that we want you to focus on is you're going to get this feedback document, right? And all of the feedback document is it's like a HTML file, it's just a file you can open in your browser. But what it looks like is it has all the questions from the assignment, right? All the questions from the homework, and then it has like your response. But then there's like a third cell, right? And then in that third cell, it's the tests that our auto grader is running to test your code, right? So it's going to be the things, like I said, there's going to be tests that are checking the output, right? So like for that that like sample question, there'll be a test that's like check or like verify that output equals 10, right? So verify that you got the correct answer and that it was outputted. But then there could also be a test, right? Like the other one that I said, which is like test that there's a multiplication somewhere in the code, right? So the feedback document is like really helpful, right, for understanding your grade, because it shows you the exact place, like tests that you got, that you passed and didn't pass, right? And the way you'll know that it's kind of like, it's kind of a confusing, it can be confusing at first, which is like the tests that you pass, there just won't be any output. Like the Python is just running through code line by line, right? And so it'll just like hit that line, it'll run the test, and if you pass it, it just moves on to the next line, right? So it's kind of like, I wish that there was I wish that it would give like a big like check mark or a smiley face or something, but as of right now, it just does the Python default when a line of code works correctly, which is it just says, cool, great, no errors, no crashing. It just moves to the next line, right? Whereas on the other hand, if you don't pass the test, that's where it will produce an output, right? And it'll produce an output called an assertion error, because a test is called like an assertion in Python. But for your purposes, all you need to focus on is it will show like a little like arrow that just points at the line of code containing the test that you didn't pass, right? So that's how you'll know like where you got points off, is you will see literally like, you'll see the test code and there'll be like an arrow, like a red arrow. Well, I guess the arrow is like black, but it's like the background of the cell is red, if that happens. And it'll point at the test that your response didn't pass, right? So that's where you want to look. It's like, if you get a question wrong, or if you get points off on a question, yeah, look for that arrow, and it will point at the exact line of code in our autograder tests. So when I say test, it's a line of code that's testing something about your response, and there'll just be an arrow pointing to it if you got points off for it. Cool. And the last thing I want you to know is that there's kind of like a table of contents listing all the questions and the numeric grade you got on them at the very top of this feedback document that I'm talking about. So when you get that right, it's like I said, there'll be a lot. There could be like 30 to 40 questions on a homework, and can be very annoying to scroll through it all. And so I would just like look at the very top. We have it set up so that there's a list of the questions, and there are green check marks for ones that you got correct, and then there are red X's next to the questions that you got wrong. And you'll see it's formatted like a link, right? And meaning that you can click on the link of any question that you got wrong if you're curious, and the page, it'll immediately jump down to that question in the document, right? So that's what I would use as kind of your sanity map. It's like, I would just open your feedback document and then look for any ones that you got wrong, and you can click on those, right? And jump down and see, and look at the test and look for that arrow to see exactly the line of code that represents a test that your response didn't pass, right? So yeah, the feedback documents are shared with you, those documents are shared with you through something called NYU Drive, which you might not have heard of, but it's not a big deal. It's just by being an NYU student, you know, NYU gives you that like Gmail interface for your NYU mail, and similarly, it gives you a Google Drive like interface basically for your NYU Drive space. And you really don't have to worry about it if you don't want to, because what'll happen is you'll receive an email, right? Just like if you get a normal, you know, Google Drive document shared with you, you'll get an email that says like DSUA111 has shared homework 1 feedback document with you, right? And you'll be able to click that and open it. I will say, like, Google Drive is very weird, and it doesn't, like, if you try to open it within Google Drive, it will just show the HTML code, which is not, you know, not what we want. We want to see the actual document, like we want to see it rendered. We don't want to see the code underneath it. So it's a little annoying, and there'll be instructions with that email that you receive. But just in case, you know, you don't want to read those instructions, the the long and short of it is you have to download that document that we shared with you. It's a .html file, right? It's a normal web file, but it's just annoying because you can't open it within NYU Drive. You have to like download it and then go to your downloads folder and like, you know, double click on it, and then it'll open in your browser like rendered normal. It'll look like what I'm talking about. You'll see the table of contents, and then you'll see the questions, your responses, and the autograder tests. Cool. So yeah, oh yeah, that's the link to NYU Drive. But like I said, if you don't want to worry about it, don't worry about it. You'll get an email each time you like your feedback document is ready that says DSUA111 has shared feedback document with you. But if you do decide to go through NYU Drive, like you lost that email or whatever, there's a shared with me tab, and that's where you'll find all the feedback documents we share with you. Cool. In case you don't want to wade through your emails. All right. Next up is Piazza, which, like I said, everything is in the sidebar, right? And so the next tab after Jupyter Hub is Piazza. Piazza, hopefully you've also already seen and Prof. JR has talked about, but it's just like a forum where in addition to emailing me, which you're always welcome to email me or any of the other TAs or Prof. JR and Prof. Sperling, but Piazza can be a little more helpful for like general questions, because not only can any of the professors or TAs respond to your question on here, but also like other students can respond, right? So if you're like, hey, can someone tell me where this like example code that Prof. JR talked about is posted or something, hopefully some other student will be able to quickly say, oh, here's the link to it. Yeah, just because like, there's like 5 TAs, but there's like 200 students. So you're much more likely to get a quick response on Piazza than over email, even though, like I said, I try to reply to the emails within 24 hours, but within Piazza, sometimes it says, I don't know what happened, but yeah, average response. So our average response time so far is 22 minutes. Cool. So yeah, email, you'll get a response within 24 hours, unless something, horrible goes wrong in my other jobs or something. And then, but on Piazza, average response time, 22 minutes so far. It might go up or down, but it's just much faster. And there was one other thing. Yeah, so on that, I wanted to say that you can post anonymously, right? Like when you make a new post, there's a checkbox that says like post anonymously to classmates. And that to classmates is key, because the point of why it specifies that is because it's not anonymous to the instructors, right? It's just anonymous to your class. So the classmates will see like posts by anonymous, but we'll see like your name and stuff. And that's just to prevent like abuse of the system, because actually like, so like I said, I TA'd a bunch of computer science classes and stuff before, and there have been instances where students, like there is a setting on Piazza to make it fully anonymous, but a couple of times like students who were kind of smart, right? They just posted like, what's the answer to question 1? What's the answer to question 2? What's the answer to question 3, right? Because there was no way to like penalize them, and we had to like just delete them. But yeah, it got a little like nutty, low-key nutty. So instead we've made it like it's anonymous to other classmates, so you don't have to feel, like, oh no, they're all gonna think I'm dumb or something. It's not, they won't see who you are, but we will. But no, I'm not like, it's not like a weird threat. I'm just like saying that's how that is set up. So cool. So Piazza, yeah, that's pretty much everything. I've talked about the gradebook. The Zoom tab, yeah, that's where you'll find all of your recordings, including this one. Seating assignments is, so I'm teaching like all remote this semester. My like hiring for this class is a little weird, right? Because basically once all that auto grader stuff happened where we had to code a new one from scratch, they kind of like changed my hiring status so that I'm like 50% like course administrator, right? Like that just means like I administrate the auto grader, and 50% TA. But what that also means is like I'm just teaching remote sections. I'm not doing any in-person teaching this semester. So unfortunately, I I don't really know how the seating assignment stuff works and like the cohort stuff. So which is just to say, like, if you email me about it, I'm happy to like go and try to find out how that, you know, what your situation is. But it's like just effectively you're probably just going to be able to get a better answer from the rest of the TA staff or from, you know, Piazza. So I'm just putting that out there. Like, I'm not going to ignore it. I'm going to, you know, try and figure out if there's something wrong with your seating assignment or anything like that. You know, I'm here to help, but I just haven't gotten any training or anything in how that works. Which also reminds me, like, I also, like I said, I'm not a student at NYU, and I didn't do like grad school or undergrad at NYU either, but Will Girdle, the head TA for the class, he actually has been at NYU for like 10 years now. He did his undergrad at NYU and now, you know, is finishing up his PhD. So like I've talked with him a bunch, right? Like me and him were TAs when we were first changing the autograder and everything. So I think the kind of arrangement is like, if you have questions about like NYU specifically, right? Like for example, about program requirements for data science and stuff like that. You know, Prof. JR is like the director of undergraduate studies for data science, and Will has spent like 10 years at NYU. So just, you know, inevitably they're going to know more than I am about like the NYU specific requirements and everything like that. So yeah, just wanted to put that out there because it reminded me. Email me and I'm happy to help. Like I know I can like look up the NYU requirements, or I can ask Center for Data Science, whatever, but I'm just kind of like newer to it than Prof. JR or Will. So I have talked with them and they're like, yeah, if your students have NYU specific questions, like you can just contact them. Conversely, like if you have Columbia questions, I'm happy to answer them, or Stanford, whatever, like, or also, like I said, computer science specific questions, you know, as opposed to like data science or social science or whatever. Yeah, you can email me about this. So, which brings me to this, which is like, what exactly is, you know, data science? It's kind of funny because it's like this like buzzword that didn't exist when I was an undergrad. When I was an undergrad, like I said, I just studied computer science and statistics as like two separate, you know, degrees. They didn't talk to each other. They weren't even in the same school, right? Like I was in the engineering school for the computer stuff, and then I was in the like School of Arts and Sciences or something for the math. Oh, I don't think I mentioned that was at University of Maryland. Yeah, I'm from like I grew up in Washington D.C., but then moved to Maryland for high school, and then went to University of Maryland. So for the first like 21 years, I was just in this little, you know, DMV bubble. But anyway, yeah. So what's interesting though is that data science was kind of created to like merge or like meld computer science and statistics. But the reason I put like social science here in brackets is because, you know, there's a bunch of, you can imagine there's a bunch of different like flavors of data science. And since you're at NYU, I wanted to include this because NYU's like data science program, just by, you know, historical accident or whatever, is pretty like social science heavy, just in the sense that like the people who were like, you know, developing the curriculum and everything at Center for Data Science early on were social scientists, right? So like Prof. Sperling is like primarily like a political scientist, for example, you know, and Prof. JR has like a really interesting, I think her PhD is in complexity theory. So, you know, more math, more like maybe like non-linear dynamical systems is, I think, is like the more technical name. But yeah, there's like a mix of different backgrounds that you could come from and do data science, right? But I'm just putting that out there that at NYU, it's pretty social science oriented. Like you could imagine some other school or some other institute or company or whatever. You can imagine like, oh, if there were a bunch of like med school people in the data science, developing the data science curriculum, that it'd be like biomedical heavy, or like it could be finance heavy, right? I'm just saying at NYU, it just happens to be like pretty they bring in a lot of social science. So yeah, like, we try to cover all the different flavors of data science, because we don't want you to just only know this one little side of it. But yeah, I just put that out there because it's going to be a little like biased. And I say bias, it's like in a good way here, right? In the sense that like that's kind of that's like what we know best, right? Is the social science side of data science. But yeah, there are other schools, right? Like if you decide, oh, I want to do data science like as a career, right? So there are other schools, there are other institutions, companies, startups, whatever, government agencies that have a totally different like take on data science, right? Like I said, biomedical or financial or I don't know, education, astronomy, right? The point being, like, you should just, if you find yourself interested in data science, you can like look at these different programs and see what their kind of like flavor is. And the last thing I wanted to say is just like through the semester, I want you to maybe kind of like take stock of what interests you and doesn't interest you about the curriculum, right? Because of this like hybrid nature of data science, there is a sense in which like different parts of it are going to appeal to different people with different types of learning styles and interests. But if you find yourself interested in like the technical side of things, like quote unquote under the hood, that's kind of the to me that's what I would classify as like the computer science side of data science, which is like the just the technical tools that you're using. Like I wanted to study computer science like originally when I was in high school and stuff, because like I actually went to this science and technology high school in the DC area, and like it was very like what appealed to me was like, oh, like how does this like computer thing work? Like how is it that when I press these buttons on this keyboard it suddenly shows up on the screen? Like what is happening under the hood, right? And that to me, like I was definitely computer science was perfect for me then, like with that interest in mind. So if you're, if we're going through this class and you're like, wait, how is it making these like graphs, or like how is it computing these things, like how does any of this stuff in Python actually work? You might want to pursue, the computer science side of things. And like you can talk to me about that, right? That's like my background. Then there's like the mathematical, more like theoretical side of things, which is where the statistics part, right? Which is like, oh, how do we know that all these data science things that we're doing are actually kind of like valid for drawing inferences about the things we're studying, right? So like, why do we know that I can go out and like survey, 100 people and draw an inference from that about the world, right? So like, if I go out and I just ask like 1,000 people, let's say, like I just find 1,000 people and I ask them their height, like, and I take the average of that, how do I know that that's like close to like why am I able to draw from that, like say like, oh, actually the world average of heights is probably somewhere around there. Like I'm starting to get, the more data I collect, I'm starting to get a better and better picture of what the sort of like full population, it's called like the population statistic is, right? So height is kind of a weird example. You can replace height with like a thing that you're interested in, like if you're interested in medicine or health, right? You can imagine like I measure people's heart rates or something like that. But the point being, like in almost every case, we're not going to be able to get the full population, right? Meaning like it's pretty much impossible to go around the world and ask all like 8 billion people like what their height is, right? Then we could get the true like average height of people in the world. We usually can't do that, right? If we can, that's literally called like a census, and it's pretty rare. But what usually happens, right, is we do a survey, right? Which means like we don't ask everyone, we ask some subset and we try to infer things about the full population from that subset, right? So the tricky thing is that not all samples are good, right? Like with the height thing, I like using that example because one time, like I was using it before, and then one time I actually looked it up, and you actually can get a like a data set where people, you know, statisticians have actually like measured the heights of people around the world, and it turns out it varies a ton by country, right? And that's where social science comes in, which I'll, you know, kind of get to in a second. But what's weird is like, so if you want to pause and guess like what the, I wonder if you could guess like what the country in the world with the tallest people on average is, and what's the country in the world with the shortest people on average, right? And you know, sadly but truly, it varies a ton by kind of like socioeconomic variables, right? So just there are places where people are able to get more and less, you know, nourishment, right? Nutrients and calories and stuff. And yeah, so if you've unpaused it now, the country in the world with the tallest people is the Netherlands. And it's pretty wild. Like the average, sadly, I only know it for males because that was like the first column, and I just looked it up real quick. But yeah, the average male in the Netherlands is 6 feet tall, whereas the shortest is actually Panama, right, in Central America, where the average male is 5'3". If you use the metric system, I'm sorry, that's my Americanness is like coming through that. I don't know what those would be in metric system, but yeah, that's a huge difference, right? That's like 9 inches. Like it's like a pretty big difference between people's heights. And I just say that because it's like, you know, going from the sample and trying to infer something about the population, right? Like the world can be tricky, right? Because, for example, if we wanted to take a sample of people in, you know, New York, and we wanted to infer about the, like that, when we can't just say, oh yeah, I think the average height of people in New York is about the same as the average height of people in the world, right? We have to actually kind of like do corrections, right? We'd have to say like, okay, well, maybe we'll take the New York height, but then if our country is like poorer than New York, we will lower that as our guess for the average height in that country. And if their country's richer than, you know, New York per capita, say, then like we'll increase that, right? So I'm just saying like statistics is kind of that's what that is. That's like the art and science of figuring out how to draw inferences about a population, even if we can't study everyone in the population, right? So cool. And that gets into social science, because the social sciences, I've been hinting at it, which is like, why do we care, right? Social science comes in that example where it's like, wait, you know, if we care about like people having enough, you know, nutrients, that and there's a social phenomena, right? Like the social phenomena, there are social phenomena that explain like why people in Panama would be much shorter than people in the Netherlands, right? You know, you can do a whole PhD, you can spend your whole life studying just that. So that's where the social science comes in. Is social science is kind of focused on like, oh, why do we care about this? Like, what are the sort of, why does it matter for people's lives, right? So, you know, I'm not one of those people who's like, oh, computer science and statistics doesn't matter for people's lives, but it's just about like, what's the focus, right? Like, what's the question on the top of people's minds, you know? So yeah, that's my kind of summary of the 3 things that you will find, I think, go into data science at NYU. So yeah, I'm recording this after the fact, so there's no one to ask questions, but yeah, questions can be emailed to me. Like I said, my contact information is back here, Malvazar. So yeah, I'm really sorry about not recording the sections I did last Friday. From now on, I will record them, and then we won't have to have this awkward extra, you know, video recording session. And you'll just get you'll be able to access the videos from the Zoom tab on NYU classes, like right on Friday evening. So yeah, thanks a bunch, and looking forward to seeing you all on Friday. Yeah, Friday, September 11th will be like our next section, live section. So cool. Thanks.